Imagine that you have an incredible microscope capable of magnifying to such a scale that you can see exactly what is happening inside every tiny individual particle. You realize that this structure is extremely similar to what modern science knows about the universe. And now you are struck by a wonderful feeling of profound insight, and you realize that, at least in theory, there could be a situation where some enormous being is observing our world in exactly the same way. And it sees that inside some mysterious particle, which at its scale is the tiniest and seemingly indivisible, there exists an entire universe. Congratulations! We have now arrived at the idea that our universe might be nothing more than an electrode. In the 1960s, the Soviet theoretical physicist Moshe Alexandrovich Markov proposed one of the most astonishing cosmological hypotheses. According to this idea, an entire universe could be hidden inside an elementary particle. A special term was introduced for such hypothetical objects: Friedmons, named after the mathematician Alexander Friedman, known as the creator of the expanding universe model. Markov's calculations showed that Einstein's general theory of relativity allows for an unusual possibility. To an external observer, the object appears to be an ordinary particle. However, inside, thanks to the colossal curvature of spacetime, there may exist a vast world of enormous scale. An object that appears as a point from the outside can, on the inside, contain a space whose dimensions are incomparably larger than the carrier itself. Perhaps this is the main scientific component of the entire question. But not everything is so simple, and not everything happens so quickly. In a general sense, the idea that an electron conceals an entire universe within itself is based on the same notion as the atom being a particle inside which there is a whole universe. The concept itself was originally purely philosophical. In Indian philosophy, there was the idea that the universe can replicate itself in different directions, both on the tiniest scale and on a very large scale. At that time, this theory was purely philosophical. In fact, it originates not only from Indian philosophy, but also has roots in ancient Greek philosophy. There, these questions were examined in great detail. Democritus, who in fact laid the foundation for our understanding of what an atom is. And in fact, these ideas were developed there in this same direction. This concept became scientific to a large extent after Rutherford's legendary discovery. You probably remember well that Rutherford's planetary model of the atom assumes that the atom has a nucleus and that electrons are located around this nucleus. Science played with this very concept for a long time, and in many ways it drew its inspiration from those very works that once existed in foundational ancient philosophy. But of course, Rutherford's ideas went significantly further, and I don't know if it's worth our time now to recall what Rutherford's atom is, to talk about the fact that Rutherford's atom has a certain specific structure and all of that. But here it's very important to mention one crucial thing. Since Rutherford's atom was named the planetary model of the atom, as you well remember, this planetary model assumed that the atom is similar to the cosmos. For quite a long time, the universe was compared to the atom at the level of a hypothesis. This served as a kind of philosophical foundation. Yes, it was now based on the idea that the atom is somewhat like the cosmos, but it still wasn't scientific. And a little later, Abraham Zelmanov published his work on the nesting of cosmological structures. Essentially, this was one of the first scientific mentions that, on cosmological scales, the universe and everything contained within it can resemble a matryoshka doll. This means that if we take apart, a matryoshka doll, as you all remember well, there's a big matryoshka, inside there's a smaller one, and inside that, yet another, even smaller one. And following this same logic, we can, for example, take apart the solar system and see the structure of a planet inside, which in some ways resembles the solar system itself. Then we can take apart that planet, look at what's inside it, something similar to an entire solar system, then look at an atom, and so on and so forth, and so on and so forth. And the whole problem here was that this logic would eventually reach a certain indivisible size. This indivisible size was already known at that time as the Planck length. And this Planck length implied that after the Planck length, something terrible and incomprehensible would happen. That is, when our matryoshka reaches the level where everything becomes extremely small, everything should fall apart or turn into something unclear or become what? That's right, those who watch me regularly know that it should become quantum foam. The question of quantum foam was actively explored by Wheeler, the very physicist who came up with the paradox of the other Wheeler, and a lot of other things as well. According to his ideas, quantum foam is the foundation of the universe. Well, if quantum foam is the foundation of the universe, then it stands to reason that what mainly emerges from quantum foam? Primarily and most significantly, particles emerge from quantum foam. And it's worth noting here that in 1975, Benoit Mandelbrot introduced to the entire world his groundbreaking theory of fractals. In essence, he formalized all these discussions about these mysterious nesting dolls into a strict mathematical form. And he emphasized that, in many cases, nature copies itself. Now, this has become mathematics. Why look for something more here, after all? It seems like we already have the answers to our questions, and even if we accept the hypothesis that the universe is hidden inside an atom as a working theory, there's no need to dig any deeper. But in reality, it did make sense to dig deeper. What is an elementary particle? An elementary particle is a particle which, according to modern physics, according to the current standard model, has no internal structure. What kind of fascinating idea might this lead us to? This can give us some very interesting and foundational ground for philosophical thought, which enables us to carefully proceed from the idea that an elementary particle actually represents the way things function. This is that primordial cosmic model. So what is the universe, essentially? Well, to some extent, it is the space in which everything that is happening now can take place. It is a certain cosmological complex structure that has no description. And this complex cosmological structure represents, in a sense, a primordial system. Well, I mean, it's probably hard to argue that everything happening around us right now is happening inside the universe. This means that the universe must serve as some kind of foundation. And if we say that there is a universe inside an atom, and that our universe is an atom, then we are playing with a hyperstructure. So when will we analyze these structures? Down to those very spheres that we imagine as a disassembled nanocube, we move to the level of the electron, or rather to the level of the elementary particle. But since the electron is one of the most interesting and fascinating elementary particles, all our reasoning comes down to it. And essentially, the entire logic of the universe inside the electron is based on the fact that the electron itself is elementary. The electron is in and of itself an electron, and at least according to the standard model, it cannot be broken down into anything else. Of course, we've actually discussed the question of what the electron is made of on the channel, and there's a link. Of course, I'll leave a link to that video somewhere. But there we said that these are still hypothetical ideas for now, although the hypotheses are quite solid, and in fact, I believe that very soon the electron will also turn out to be a composite particle. Why? We'll talk about this topic separately at some point and make a separate video about why exactly this limit, the indivisibility, will never actually be achieved. I think this is an interesting question. If you find this interesting, of course, give it a like right now. So what do we actually have as a result of all this? We have that the electron is, for us, a blank slate. And since the electron has a certain space-time model, a universe could exist within it. I'm not imposing this opinion on you, I'm not insisting on it, we're just discussing it together right now. This interesting, strange, and rather bold hypothesis that we are living inside an electron. And for this model to work, we need to accept the circumstances that it implies. Now let's take a look at something else. The logic itself is largely determined by the fact that at some point solutions to the equations of general relativity appeared, and the concept of things like Einstein-Rosen bridges emerged. These are essentially what we call wormholes. The mathematical formalism of this phenomenon leads us to the existence of black holes, and moreover, if we delve deeper into all of this, the internal regions of black holes have a strange and complex structure. This strange complex structure cannot be encompassed by the concept of a singularity alone. And this complex structure implies that inside a black hole, it is theoretically possible to have a space that forms its own space-time. And here, it's important not to confuse the word space, as I used it, meaning volume, with the kind of space that is a specific structure of our surrounding world. And so based on those equations that gave us wormholes, in essence, an idea has formed that inside a black hole there could be an entire complex spatial structure. We touched on this topic quite a bit in the video, where we discussed the structure of a black hole as the foundation for a universe. Yes, such a hypothesis exists in a fully serious form, and it is being thoroughly developed. In other words, it is possible to assume that we live inside a black hole, but that's another hypothesis which we won't discuss right now. We're just going to mention it in passing, and if you're interested in learning more about it in detail, of course, there's a video on the channel, and the link will be hidden somewhere. At this point, you might say, well, black holes, okay, let's say they seem to exist now. It seems like something has been proven, sort of. There is a mathematical formalism for all of this, and it even seems like there's some infrastructure in place. Let it be so. Let there be an entire universe hidden in there. But how does this even work? What does this have to do with the electron? Why are you telling us this now? Why are you confusing us with all this? The connection is actually very, very simple. At the very beginning, we mentioned the works of Moshe Alexandrovich Markov and noted that by reworking these mathematical descriptions and complex distortions, we can assume that an entire world might be hidden inside a point-like object. Any elementary particle can represent a certain fundamental oscillation of a field, a certain energy that in fact mirrors what exists inside a black hole. I understand that right now all of this is mixing together in your head. I understand that you don't understand, sorry for the tautology, what I'm talking about, but in fact, this is the basis from which we proceed, and already at this point the hypothesis seems rather strange and quite controversial. But just imagine, essentially, we're saying that inside an electron there could be an entire world because in many ways its internal structure, which we cannot comprehend, mirrors the structure of a black hole. Quite intriguing, isn't it? But this is the fundamental idea. And then this fundamental idea unfolds further. As a result, in such a scenario, our universe appears to be the interior of an elementary particle. There is a much more interesting approach to this question, which makes us think about it in greater detail. I understand that the idea of all these vortices, this vortex physics, which I don't fully understand, and it's not even really physics, but rather some kind of offshoot, makes us think it's complete nonsense and utter rubbish. But there is one circumstance that concerns the electron specifically. So, my friends, what makes the electron so interesting? Besides the fact that an enormous number of works have been written about the electron, and a huge number of popular science videos have been made, the electron always generates an unprecedented level of excitement. The electron is interesting to many because there are no two different electrons in the universe. You might say that there are no other particles that would be different, that if a particle is of a certain type, it will completely replicate each other. Well, in many ways you are right. Theoretically, perhaps, some particles that are elementary really will be identical, but the electron has been studied very thoroughly. And essentially, two electrons in the universe which we take from different want to be absolutely identical. They will have the same spin, they will have the same characteristics, they will have everything identical that we have managed to measure. This very identity itself has in many ways led us to consider the electron as the perfect candidate for hiding an entire structure inside it. And now it's time to talk about fractal structures. Essentially, what we discussed as a way of copying the universe at different levels, everything that we remembered about Indian philosophy. In science, this is called a fractal. And if we usually say that all of this is just a hypothesis, then it's unclear what exactly. Then in the case of fractals, it's a fully developed, well-established mathematical logic. The theory of fractals requires one simple condition. It needs objects to copy themselves perfectly, otherwise the whole idea of fractals falls apart. So what is a fractal? There's a really good GIF, I'll insert it here, that shows how we take some strange structure and start to zoom in on it. And as we zoom in on this strange structure, at each new level we see a copy of that same strange structure. This essentially is what a fractal is. It also works in the opposite direction. When we zoom out from the structure, essentially the fractal will replicate itself on a larger scale as well. And it just so happens that there are a huge number of fractals in nature. Fractals are a wonderful approach that allows us to build a sound logic for studying a wide variety of phenomena. Starting with, for example, the shape of the coastline, I think in the Netherlands or somewhere like that, they give such examples and it goes all the way to the structure of various systems. This fractal logic allows us to rely on nesting. And as I already mentioned, fractal logic implies that the very source of fractal reasoning must be perfect. And as we noted a bit earlier, the ideal particle for replication is the electron because the electron itself is perfect. Two electrons are perfectly identical to each other. And if we continue to develop fractal logic, we need every object containing a new universe must be perfect. However, there is another opinion here which is based on the first point we discussed, and it sounds very interesting. It seems that the electron is a particle that has no structure, but there are also hypotheses suggesting that the electron might actually have some kind of structure. So what should we make of this? It's not very easy to simply say that we don't understand what structure exists inside the electron, and therefore the structure could be extremely complex. The structure might go beyond the boundaries of modern physics. The structure could push us towards smaller characteristic object lengths and take us down to the Planck length scale. And if that's really the case, then with the tools of modern physics, we can't explain what structure exists inside the electron, what kind of structure is there, how to describe it, or how to conceptualize it. In fact, we also can't imagine what the structure of the universe is. We can't imagine why the universe is constantly expanding. Although there are some scientific comments on this, in a general sense to some extent, it's fair to say that we don't know why the universe keeps expanding. And if we don't know how the universe is structured, if we don't know how electrons are structured, all of this is in some way theoretically similar to each other but equally incomprehensible, then the electron is the universe itself. So our universe is in fact an electron within some gigantic object. So why couldn't our universe be an electron in the atom of a giant? By the way, this is actually a perfectly scientific phrase which was formulated by one of the physicists. But this entire perspective on the problem comes up against the fact that sooner or later, theory is shattered by facts. And the idea that our universe is hidden inside an electron runs into the problem that it is impossible to either scientifically confirm or refute this. Nevertheless, we can refute some aspects of this theory, and we would be absolutely right to do so. To begin with, perhaps the most important and frustrating thing is this. It must be said that, for modern physics, the electron is a point particle. What is a point particle? By the way, this is yet another source of paradoxes and another source of misunderstandings, which, incidentally, we have also discussed at some point. A point particle is essentially a point. A point is a zero-dimensional object. What is a zero-dimensional object? It is an object that has no dimensions except for its coordinate. So how can we imagine that? Imagine you're trying to fit a picture of a dog that's 3 centimeters in size into a drawn circle with a diameter of 1 centimeter. It just won't fit in there. That's pretty much the same idea here. A point simply doesn't have enough dimensions to fit anything inside it. And so, according to modern physics, the electron is a point-like object. A point-like object that has size. I understand that sounds crazy, but a point-like object limited by its very point-like nature. What matters for us now is that a point-like electron also implies certain behavior in specific dimensions. This means that inside the electron, you can't stuff anything in there in this context. And in order for the hypothesis of a universe inside an electron to start working, we need to say that the electron actually has some kind of structure, which contradicts the standard model and also contradicts the idea that it is point-like. So here we run up against the strictly constructive concepts of modern physics, which have been tested in practice versus those ideas that seem real to us but are actually hypothetical. And in this scenario, a universe inside an electron simply cannot exist in any way. Here one could refer to the works of Markov, which seem to use zero-dimensional objects, but the point is that it's not about zero-dimensional objects, but about extremely small objects, about objects that approach infinitesimal size. These are not zero-dimensional objects. These are slightly different things. But in addition to this, there is also the fact that, indeed, fractality runs into certain boundaries. It would be great to use that very radical model we discussed, in which we said that fractality works from infinity in one direction to infinity in the other. But unfortunately, or perhaps fortunately, it apparently doesn't work that way. And as we remember, the universe is homogeneous. This was once stated by Copernicus, and in fact, no one really disputes it. The distribution of the structure of the universe is extremely homogeneous. And this copying of the universe in different directions, this is where it ends. Why does it end? Well, because in order for there to be a fractal, how is it easiest to imagine? Take, for example, that image which looks like some coast of Spain, or perhaps the coast of the Netherlands. Examples are given here, and look at how we could copy it multiple times, enlarging it each time. In order for it to be copied, it needs to be non-homogeneous, otherwise there's nothing to copy. It's hard to talk about homogeneity when we're dealing with objects that, by their very nature, cannot have distinctive features in their internal structure. There's simply nothing to copy at that level. And for the hypothesis of a universe inside an electron to work, the fractal model would have to work perfectly. But the fractal model cannot work perfectly because the universe is homogeneous. In other words, there's simply nothing for us to change, and at some point the fractal model fails. So if we are inside the electron and the fractal model has revealed itself, then our level stops there. We fall into an infinite and boundless space. What does this mean? It means that fractality is everything, and if we proceed from this hypothesis and try to scientifically apply it to social fractals, then the scientific validity here falls apart. The next point is related to physical constants, and in general to the dimensional factor. Well, as you remember, one of the main problems of modern physics is the impossibility to somehow reconcile general relativity and quantum mechanics. That is, we have two types of physics existing within the same world, each with its own rules. How this happens is a topic for a separate discussion, but nevertheless it does happen. One way or another, this boundary shouldn't exist. In other words, just as with fractals, we should be able to move along this line equally in both directions. And we shouldn't have different formulations for different systems. And then there are the fundamental constants, which are a huge problem. Why? Because fundamental constants work at one level but don't work at another. Roughly speaking, from another angle, we've approached the theory of everything. And again, we've looked at the fact that it's impossible to reconcile two types of physics at different levels, and that's just two types of physics. Now imagine how many different patterns there will be when we dig down to such deep levels as the fundamental structure of the universe. Here, everything is much more complicated than we would like to see it, and so the issue with the constants and the impossibility of reconciling the two types of physics works against the idea that the universe is hidden inside electrons. The next point is the dimensionality of space. What does the dimensionality of space tell us? In true fractals, we encounter fractional dimensions. This is a common occurrence. Moreover, it is supposed to be that way there, while in the real universe we encounter three dimensions. All of physics, in the current context, is built on this specific number of dimensions, in whole integer values. It must be 3, it must be 4, and so on. Space, as it exists, has a certain fundamental and standard structure. The standard structure assumes an integer number. We will talk about these fractional dimensions at some point, or I will write a separate article on this topic. It's all quite interesting, but still, essentially, this fact at the moment in our current understanding brings our discussions about the fractality of the universe back down to Earth. And essentially, we understand that the idea based on the universe being inside an electron would have to assume that we have an infinite number of fractional dimensions. And is it even worth mentioning the issues of falsifiability and testability here? Is it worth bringing up the criteria we discussed when we actively criticized the idea of the universe inside an atom? And is it worth saying that this is impossible to verify? Moreover, it's impossible to even criticize this. I always bring up Karl Popper's idea here, if you remember him. Physical logic and his logic of constructing ideas were based on the notion that a hypothesis doesn't necessarily have to be well supported. What matters is that the hypothesis must be open to criticism. And in order to criticize a hypothesis, you need to start from existing concepts. We don't have a bridge that connects the existing concepts in the form of mathematics with the hypothesis that, in this particular case, is present. And criticism of the idea of a universe inside an electron didn't take long to appear, and even those people, even those scientists, who themselves put forward rather ambiguous ideas and theories, were highly critical of it. The idea that the universe is hidden inside an electron. From these people, there was more criticism regarding the universe inside an electron than there was about the universe inside an atom. And the idea itself seemed completely, well, let's say inappropriate, even crazy. Many scientists noted that even Smolin's ideas about the complex mathematical structure of space inside black holes, which led to the thought that our universe might be inside a black hole, are much more developed and precise than the notion that the electron is the foundation of our universe. Susskind himself spoke up right away. You'd think that, well, he's the kind of person who, I'm not sure how to put it, comes up with things that are completely out there. But even he said that the electron and the universe are things that are hardly compatible. In many ways, as you can imagine, he was coming from his favorite string theory. And this idea turned out to be incompatible even with string theory. Why am I smiling? Because string theory is not always perceived unambiguously in the scientific community, and the very concept of a huge number of dimensions, although it may seem logical, actually leaves standard physics at a dead end. The standard model in many ways simply doesn't understand how to actually work with this, even though the theory seems advantageous and the theory seems convenient. But even, in fact, Susskind himself said that somehow this basic logic of the electron and the universe just doesn't fit together. Well, and what did David Deutsch have to say about what is stated in the electron hypothesis? That the universe equals the electron does not make any concrete predictions. In order for a hypothesis to be something that claims the status of a theory and corresponds to some reality, you need not just a mathematical formalism, but also some starting points to even begin talking about it. In the case of the electron, again, there are no concrete starting points. It seems that in this whole story, we're descending to the level of Isaac Asimov. I'm not trying to say that he's somehow wrong or uneducated. His works aspire to the title of serious science fiction, specifically science, specifically fiction. And he really worked through his writings in great detail, very competently and an interesting author from a scientific and popular science perspective. Nevertheless, the works that he, in fact, published cannot in any way claim to be scientific theories. These are all hypotheses, some kind of logical speculations, and essentially all of this is just fragments of his opinions. One way or another, this idea of the hypothesis of a universe inside an electron originates in the form we see it on the pages of Isaac Asimov's books. In 1972, he published his work, Worlds Within Worlds, and within these concepts he explores precisely the idea of fractality. Among the many works, there were studies about a universe inside an atom and about a universe inside some other objects. There was also a work dedicated to the universe inside electrons. In fact, what we are discussing is the realm of science fiction, a genre of fiction that became widely recognized primarily thanks to the visionary literary works of the author Isaac Asimov. However, it wasn't just Isaac Asimov who wrote on this topic. There are other science fiction works as well. But one way or another, we always come back to a concept that sounds more like science fiction than a physical theory or even a physical hypothesis. So essentially, we've just discussed an interesting idea that has the right to exist, but in no way claims, most importantly what we're interested in, scientific validity or alignment with what in fact physics is trying to teach us. So all of this is interesting and exciting, but apparently it does not correspond to reality. I hope this material will be useful to you. I hope you found it interesting, and as always, if that's really the case, I would ask you to support the project with likes. Your likes are extremely important because if the channel grows, I can devote more time to it and make new videos for you. Let me also remind you that you can support the project via the link in the description and ask any question that interests you. The channel also has a Boosty page, and if you subscribe to Boosty, that will help a lot as well. Well, so, what else is there to say? We've covered the most important things. Thank you all for spending this time with me. Thank you for your attention and see you next time. Wishing you all the very best.